Okay, let's start with our name and date for today's notes. Our lesson is 4.3, Graphing Linear Non-Proportional Relationships Using Slope and Y-Intercept. Maybe that will help that word a little bit. Pages 101 to 106. Our essential question is, how can you graph a line using slope and y-intercept? And what we're going to look at today is our slope-intercept form of our equation. Y equals mx plus b. What we need to understand is that the m is our slope. That is, it is a set of directions how to get from one point to another point on the graphed line. You should remember that one of the things that I showed you with slope is that our m is how far up or down we go over how far to the right. And that is one of the reasons why I say it's a set of directions how to get from one point to another point on the graphed line. And what we just recently learned is that our b is our y-intercept value. In other words, we can take that value, ordered pair, that we can then plot and that becomes your starting point. And then from your starting point, then you can use your slope as the set of directions to get from one point, that point, to another point on the graphed line. In your book, on page 101, you have this example. In this example, it wants you to graph y equals 2/3 x minus 1. I realize you can't see that very clearly, but it's y equals 2/3 x minus 1. It gives you step-by-step directions. It also goes through y equals a negative 5/2 x plus 3. Again, step by step. And what I want to do is I want to do one of these with you right now. Normally when we graph, we're going to want to do it on, but I'm going to sketch this in. I really don't have enough room here, so I'm going to turn my page. And the first thing I'm going to do is I'm going to look at what I'm doing. Graph y equals 2/3 x minus 1. Now what do I know from that? Well, I know my slope is equal to 2/3. And what that means is that I'm going to go up 2 and then turn and go to the right 3, because both of these are positive. I also know from this, remember that the negative has to go with the 1, that I can go and plot 0, negative 1. This is where I'm going to start. Now, I'm going to sketch in a graph. I'm using a scale of 1. Oh. Let's mark negative 1 there. Okay. So I start from my y-intercept, 0, negative 1, and I'm going to plot that point. Then I'm going to follow my directions. My directions are, I want to go up 2, so there's 1, 2. Then I'm going to turn and go to the right 3. And here's 1, 2, 3. Then I'm going to plot that second point. And what I need now is I need a ruler. I need a straight edge. And I don't seem to have one here, so I'm going to take a piece of paper I have here and fold it a couple of times. What I'm going to do is I'm going to line that straight edge up. I'm going to draw a line from edge to edge of my graph and put arrows on it, and I will finish by labeling with my equation. Now those are some things that I want you to know, that I want you to do on every graph that you do. Number 1, always use a straight edge to draw your line. It could be a ruler, it could be an index card. Those are just some suggestions. Number 2, you're going to draw a line that is edge three. You're going to put arrows on both ends of the line. And last, you label with the equation. This is what I require for graphs. I usually do require that they be on graph paper, as long as you're careful at this point in time until we get to actually using a lot of graph paper. If you have to draw it, then try and sketch it neatly. Remember, I'm trying to model for you what I expect you to do. That's example 1. For example 2, we're going to look at the book again. This is a real world example. It starts on page 102. Ken has a weekly goal for the number of calories he will burn by taking brisk walks. The equation y equals negative 300x plus 2400 represents the number of calories y Ken has left to burn after X hours of walking. And again, the book is going to take you through step by step. So let's start with what they did. And I'm just going to pull the important information, like the equation. And what do we know from the equation? Well, we know the slope. And I'm going to represent the slope as a fraction. So I'm going to take the whole number, negative 300, over 1. And it's really not a whole, it's an integer. That means I'm going to go down 300 and to the right 1. Okay. We also know our y-intercept is 0, 2400. Now again, I want to sketch a graph. In this one, I'm not going to be able to use a scale of 1. So I'm going to do a different scale. At least on the y-axis, I can't use a 1. Okay. Each of these is going to be worth 600. And the scale that I'm going to use over here is 2. Okay. And again, we start by graphing our y-intercept, which is 0, 2400. And then I want to go down 300 and to the right 1, but I'm going to do down 600 and to the right 2. That's equivalent to this because I can reduce this and get that. So if I go down 600 and then to the right 2, my second point should be right there. And again, I'm going to take my straight edge and draw a line from edge to edge of my graph, put arrows on it, and label it with the equation. Now, if you turn to page 103, there are a couple of questions up here at the top. And it states, after how many hours of walking will Ken have 600 calories left to burn? As well as, after how many hours will he reach his weekly goal? And what we can do is use the graph we've built to figure that out. Well, the first question was, after how many hours of walking will Ken have 600 calories left? Well, he's going to have 600 calories left right about after 6 hours. So that first answer is after 6 hours, he will have 600 calories left to burn. And then the second part of that was, when, after how many hours will he reach his weekly goal? Well, apparently his weekly goal is 2400, so that has to be at 0, which is right there, which must be 8 hours. He's met his weekly goal. Okay, and those are our notes for today.